Good morning, welcome back. All right, here's our new stuff for today. We're gonna do some scientific notation. Okay, that's blurry. Good. Oh, hey, it did that by itself. Okay, scientific notation. Scientific notation is used to describe very big or very small numbers in a way that does make more sense. If you are new to scientific notation, it can look scary, and the purpose of today is to eliminate all of that confusion, because it's actually really nice, and I will show you here and now why. Cool. Today we're gonna do turning numbers from their long form into their scientific notation form and vice versa, and also we're going to figure out how to multiply and divide in scientific notation, and then we'll do some practice on all of that stuff. I could write that down, I guess, if you want an index. Okay, scientific notation lets us write scientific notation. Lets us write really big and really small. I was like, wouldn't that be funny if I made big and small? I don't know if that actually works on film because you're trying to read this, and that's actually kind of annoying when I write things really small. Okay, so this says really big and really small numbers. Easily. Yay. Today we're going to learn how to we'll learn going from long form to scientific notation and backwards. So we'll go both long form to scientific notation and scientific notation to long form. Don't worry, you'll get this. And also we're going to learn how to multiply and divide in scientific notation. Good, let's jump in. Here we're going to learn how, and then in the next video we'll do a whole bunch of notes. Okay, so let's start with this going from long form to scientific notation back and forth. Scientific notation uses, I'm going to write sci not, scientific notation, I'll write it out. Okay, scientific notation uses this times 10 to this something to show how many place values to move your decimal. Keywords, place values, move, and decimal. That was most of the words. Okay. So we operate in base 10. Every place value is 10. So like 10 is 10 times 1, 100 is 10 times 10, 1,000 is 10 times 100. Every time you move your decimal, you are multiplying or dividing by 10, just in our base 10 system. And that something shows us how many times to move our decimal. So if we've got let's just give a few examples. Let's say we've got 2 times 10 to the 2. This 2 here shows that we will move our decimal 2 place values. Okay, so that exponent of 10 shows how many times you're going to move your decimal. So in this example, here's our 2. Our implied decimal starts here. This is one place that sometimes folks get confused, which is that if there's no printed decimal, the implied unprinted decimal is just to the right of the number. Like, it's just at the end of the number. So you'll note I did not write a decimal up there. You'll note that you don't need decimals written in numbers, like, usually, unless there is a decimal, right? Like most numbers we don't put decimals. But you kind of know that they're there anyways. Here's another example. 426. Even if I don't write a decimal there, you know from like life or whatever that the implied decimal is right at the end of the number. If you've got questions about where the implied decimal is, let's connect. I'm not going to go deep on that right now, but we totally can, because every year this is like sometimes a common source of confusion. Your implied decimal is at the end, at the right side at the end of the number. If you want to hear that a few more times and write it, go for it. I'm going to keep on keeping on. Actually, if you don't want to write it, fast forward. You don't have to write this. The implied decimal is to the right of a written number. Okay, but back to our original example. We were looking at 2 times 10 to the 2. This exponent shows that we'll move the decimal 2 place values. Here's where I got into where is the decimal, even though it's implied. We're just going to come around here. So we start with our decimal here, and we say it's times 10 to the 2. So we're going to move our decimal 2 times, 2 place values. Okay, we could that, great. Because the exponent is positive, it'll be a positive long form number. That's the wrong word. It's a large. There's so many ways to think about this. So you have a positive exponent. You're going to move your decimal to the right. Move decimal to get a large number. Okay, there's our implied decimal. We're going to move it to the right because it's positive. We're going to move it 2 place values because it's a 2. 1, 2. fill in each time that you move your decimal, fill in with zeros. We moved our decimal 2 place values because of this little 2. We moved it to the right to make a big number because it's a positive exponent of 10. Great. We're going to write when your exponent is, so this is scientific notation. When your exponent of 10 is positive times 10 to a positive number, that means it is big. It is a big number. Let's do 3 examples here. 6 times 10 to the 4. Move your decimal 4 place values. It's positive 4. This will be a big number. Move the decimal to the right to form a bigger number. So take that implied decimal, move it 4 place values to the right, 1, 2, 3, 4. Fill in all of these place values with zeros. We moved it 4 times. We filled in with zeros. These things here are the same number. So 6 times 10 to the 4 is the same thing as 60,000. Let's do another one. 3.9. I said that I would do examples in a different video, but apparently I'm doing them here. 6.9 times 10 to the 5. Let's just go for it. Here's another positive exponent of 10. Positive exponents of 10 are going to be big numbers. We're going to move our decimal to the right because it's a big number. That times 10 to the 5 means we're going to move our decimal 5 times. Here we've got a printed decimal. Pick up your decimal. It's not here anymore. Your answer will only ever have 1 decimal in it. So you're going to pick up your decimal and move it 1, 2, 3, 4, 5 times. It'll wind up over here. Fill in all of these loopies with zeros, and your final answer is that. Now, when we started this video, we said that scientific notation can look intimidating because of the times 10 and the exponent. We're going to get negative exponents on the other half of this page. They can look intimidating. What's nice about them is that they take these like kind of super big numbers with like all these excessive zeros, and they turn them into kind of their essence, you know, like the number itself and how big it is. So once you get comfortable with this kind of stuff, you will be able to see that 3.9 times 10 to the 5th is just a really big number. It's a magnitude 5 number, you know. 6 times 10 to the 4 has a value of 6, fine, but kind of what's super interesting is it's got a magnitude of 4. And it's nice because they're fields of science, and that's, I mean, kind of chemistry, kind of a little bit, but they're physics and astronomy specifically are fields of science where like there's research going on where folks are like, I don't really care what the base number is, I want to figure out what's the magnitude of this number I'm looking at. So think stuff like space, you know, like big space research. We're like, we don't even know how we would know what that number is. What we're looking for in our research is what is the magnitude of the thing we're looking for. Just to put that out there. Scientific notation is actually very handy, and we will use it throughout the quarter. Both quarters, actually, Chem A and B. Okay, so here's kind of some examples on how to how to expand is what we say. So since these are the same numbers, this is the number in scientific notation, this is the number in expanded form. Let's take a number in expanded form and turn it into scientific notation. Okay, so that's kind of an unwieldy number because of all those zeros, and like anyone, like it's super easy to drop zeros, and yet you get a totally different number if you drop them. Okay, so your implied zero is always just to the right of the written number, so our implied decimal is here. You will note that there is no decimal written there, which is important because if there was, all of those zeros would be significant. However, there's no decimal written there, and they are not significant. Okay, so to go from expanded form to scientific notation form, we're going to pick up our implied decimal and move it until it is after just the first significant number. So we're going to wind up with our decimal there. We want, in scientific notation, the decimal is always behind, you have one place value in front of the decimal, and then there. Decimal. I had one kid one year who thought of it as decimal is always between the biggest two place values. And that actually also is going to make your life way easier. There's a chance you've not seen scientific notation before today, but as you go into more and more stuff, having everything being just one place value in front of the decimal is very smooth and clean and stuff. Okay, so we're picking up our implied decimal at the end of the number. We're going to move it until it is between the two biggest place values. Here we go. 1, 2, we're going to count, that's important. 3, 4, 5, 6, 7. So we moved our decimal 7 times. Moved decimal 7 times to go from where it started to where we want it, which is in between those biggest two place values. So we moved our decimal 7 times. We're going to write this. The decimal winds up here between these biggest two place values. And, okay, that's where the decimal winds up, times 10. Each place value is a times 10. We moved it 7 times. And our expanded form number is a big number, so therefore our exponent of 10 is a positive exponent of 10. These are the same number. We can do one more just because why not? That's your expanded form. Here's your implied decimal. We're going to pick it up. 1, 2, 3, 4, 5. We want the decimal between the biggest two place values. Decimal winds up here. There was no written decimal here. These zeros are not significant. They're gone. But they do show magnitude. We moved our decimal 5 times. So to show that we moved it 5 times, we're going to write that times 10 to the 5th. That does show up. Okay. And these are the same number. And instead of all those zeros, we can just say that is whatever the number is. Here it's 1.96 times 10 to the 5th. And that tells us that our number has a magnitude of 5. It's got 5, it's size 5 number. Okay, so we did a bunch of examples with positive exponents of 10. If your exponent of 10 is a negative number, that means your expanded form, your actual number is a small number. So if you've got a positive exponent of 10, it's a big number. Move the decimal to the right. If you've got a negative exponent of 10, it is a small number. And move the decimal to the left. So let's do 3.2, and here we're going to get an exponent that is a negative exponent. 3.2 times 10 to the negative 5. The idea is the same. This times 10 to the whatever is showing a really big or a really small number. It's negative exponent here, so it's a small number. To expand it to its expanded form, we're going to pick up the decimal's written, that's nice, and move the decimal 5 times to the left to make it a small number. Pick up your decimal, 1, 2, 3, 4, 5. Decimal is going to wind up over there. Fill in all of these little bumps with zeros. These are the same number. And again, it's nice because this shows you this is a magnitude negative 5 number. You don't have to deal with all those zeros. Here's another example with a negative exponent of 10. Let's say negative 3. Same deal. Pick up your decimal, 1, 2, 3. Decimal is going to wind up over here. Fill in your bumps with zeros, 1, 2, we moved it 3 times, fill in the bumps with zeros. These are the same number. If you are starting with a expanded number, and you want to turn it into scientific notation, do it the opposite way. Pick up your decimal, move it 1, 2, 3, 4, 5, 6. You're going to stop once your decimal is in between your 2 biggest significant place values. So here that puts your decimal over there. We moved it 1, 2, 3, 4, 5, 6. We moved our decimal 6 times. This is a small number. Small numbers have negative exponents of 10. We moved it 6 times. That will be, these are the same number. This is the expanded form with all the zeros written out. Here's the scientific notation form with the same magnitude, except here we express it as a number that shows the magnitude instead of all those zeros. Okay, I think you're getting the idea of it here. This is 2250. I'm actually going to make a second video. Okay, so I didn't need that timestamp. This is just a timestamp. I'm going to make a different video showing you how to multiply and divide.